For years, the United States military has been quietly pouring resources into a top-secret program that has captivated the imaginations of aviation enthusiasts and defense analysts alike. The name of this extraordinary project is the X-44 Manta, a rumored advanced stealth aircraft designed to push the boundaries of current aviation technology well beyond anything the world has seen. Just as we thought modern air warfare had reached its pinnacle, the Pentagon revealed details that catapulted the X-44 Manta onto an entirely new level of fascination. And at a development cost of around $300 million, it's clear this was no ordinary side project changer. According to the information that has finally been made public, the X-44 Manta has always been envisioned as a revolutionary leap in design and capability. Early conceptual drawings depict an aircraft without a tail section, unlike any standard fighter jet in service today. Such a sleek, seamless airframe suggests minimal radar signature and improved maneuverability. For years, rumors swirled around the shape of this craft, the specialized materials that might have been used in its construction, and its highly experimental propulsion systems. A lot of those rumors, it turns out, were correct, and as more data continues to surface, foreign powers like Russia and China are taking an especially keen interest. Some would say they're more than a little nervous. But what exactly is the X-44 Manta capable of? Why would the American military invest hundreds of millions of dollars in a design that, on the surface, appears so experimental, it almost defies conventional aeronautics? And given the threats posed by state-of-the-art Russian and Chinese fighter jets, how does this aircraft stand up when the stakes are highest? There are also major questions surrounding its stealth features. Is it truly invisible to radar? Or does it simply push the limits of conventional low observability to unprecedented extremes? There are so many questions, and in this video we'll dive deep into every known aspect of the X-44 Manta, shedding light on its origins, its flight characteristics, its rumored weapon loadout, and its potential for changing the face of modern warfare. Yet before we get into the heart of this story and uncover the secrets behind the X-44 Manta, I have a small request. If you enjoy content that explores the cutting edge of military technology, the secrets of advanced aviation, and the intense competition unfolding in the skies among the most powerful nations on Earth, then I encourage you to subscribe to this channel. Your subscription, along with liking this video and leaving a comment, goes a long way in helping us bring you more in-depth and up-to-the-minute content on topics just like this. So, please take a moment to subscribe and let us know your thoughts in the comments. We truly appreciate your support in growing our community, and now that we've got that covered, let's return to our deep dive into what might be the most mysterious and groundbreaking aircraft in American military aviation. The story of the X-44 Manta begins roughly in the late 1990s and early 2000s. At that time, Lockheed Martin, already a dominant force in defense contracting, was seeking to build upon the success of the F-22 Raptor, a fifth-generation stealth fighter that arguably changed the way air dominance was defined. The question wasn't just how to make a better F-22. It was how to push beyond the known envelope of aeronautical engineering and produce a plane that might eliminate or radically reduce many design elements that had become standard in 20th century aircraft. This quest led to the X-44 Manta concept, in which the tail section and other traditional control surfaces were reimagined or removed altogether. The main driver behind this radical concept was stealth. The fewer protrusions an airframe has, the simpler its radar signature. You see, angular surfaces and extra appendages on a typical fighter jet tend to catch radar waves, creating detectable returns on enemy radar systems. By removing those surfaces and implementing sophisticated thrust vectoring technology, engineers could theoretically control the plane's pitch, roll, and yaw with engines alone, while also minimizing the aircraft's radar cross-section. If that goal could be achieved, the X-44 Manta would become an airborne ghost, an aircraft that might appear on radar screens much later than conventional jets, if at all. But stealth alone isn't enough to justify such an expensive and time-consuming project. After all, the U.S. had already mastered stealth with aircraft like the F-117 Nighthawk, the B-2 Spirit bomber, and the then-new F-22. What made the X-44 Manta special was the potential for combining extreme stealth with super maneuverability, an ability to outturn, outroll, and outclimb everything else in the sky. That's where thrust vectoring came in, with advanced thrust vectoring nozzles that could angle and direct the powerful jet engine's exhaust. The X-44 Manta concept promised near unparalleled aerial agility. Such agility would be a nightmare scenario for adversaries, especially if the aircraft was also armed with next-generation weapons. There are many rumors surrounding the X-44 Manta's speed. Some allege that it is capable of surpassing Mach 2, meaning it can fly at more than twice the speed of sound, similar to, or even faster, than the F-22's top speeds in certain configurations. Others claim it can sustain supersonic cruise without afterburners, a quality known as supercruise, which has been a hallmark of next-generation fighters like the F-22 and some versions of the Eurofighter Typhoon. The ability to supercruise allows a fighter jet to approach targets, engage, and retreat much more swiftly than one that needs afterburners to reach supersonic flight. But let's move deeper into the design. The fuselage of the X-44 Manta, based on descriptions and the limited official data, is shaped to minimize edges that radar can bounce off. The air intakes might be contoured and canted in such a way that incoming radar waves are deflected away from the source. The leading edges of the wings could be angled at just the right degree, once again to reduce radar signature. Moreover, advanced composite materials might be used in the aircraft's skin to absorb radar waves rather than reflect them. This is often called radar absorbent material, or RAM for short, a staple of stealth technology. While RAM has become relatively commonplace in stealth aircraft, the X-44 Manta may utilize an even more refined or advanced formulation. We're talking about materials that can handle both the extremely high temperatures associated with supersonic flight and also scatter or absorb the radar signals used by potential adversaries. The aspect of flight control is absolutely critical in a tailless design. Normally, you need vertical stabilizers and a tailplane to manage yaw and pitch effectively. By removing those, Lockheed Martin had to develop or at least conceptualize a flight control system that relied almost entirely on the engines for directional control, supported by small control surfaces built into the wing itself. This means advanced software, possibly enhanced by artificial intelligence, would be tasked with continuously making micro-adjustments to keep the aircraft stable. We're not just talking about a slightly more complex autopilot. We're talking about flight control computers that might recalculate thousands of times per second to compensate for even minor shifts in airflow. The technology behind that kind of system is nothing short of cutting edge. In many ways, the X-44 Manta program foreshadowed the direction that modern drones and unmanned combat aerial vehicles, UCAVs, would later take. As for its armament, details remain as elusive as the rest of the aircraft's capabilities. Still, there are clues. An aircraft with a stealth profile like the X-44 Manta would almost certainly carry its weapons internally, much like the F-22 or the F-35. This reduces drag, preserves stealth, and allows for rapid engagement of airborne or ground-based targets once the weapons bay doors open, albeit briefly. Because the X-44 Manta is rumored to have large flat areas in its design, it might be able to carry a significant payload of air-to-air missiles, air-to-ground ordnance, and even experimental weaponry. Some suggest that the aircraft could be outfitted with laser-based or directed energy weapons in the future, though that remains speculative. However, given ongoing research into high-energy lasers and advanced electromagnetic weapon systems, it wouldn't be surprising if the X-44 Manta was prepared to integrate them at some stage. Let's address the question of why exactly the Pentagon would declassify parts of this project, and at the same time, why so much of it remains cloaked in secrecy. Typically, declassification can serve various strategic purposes. For one, revealing some details about a highly advanced project can serve as a deterrent. It signals to rivals that the U.S. is not just resting on the laurels of existing stealth jets like the F-35 or the B-21 Raider. It's continuing to innovate at a rapid pace. This demonstration of technological superiority can cause potential adversaries to rethink or at least slow down any aggressive tactics, knowing that an unforeseen, next-generation weapon system could be lurking on the horizon. On the other hand, the secrecy that still shrouds the X-44 Manta could be due to ongoing testing or the presence of capabilities that the Pentagon doesn't want the world to know about it. Now, considering global tensions and the ever-evolving chessboard of international power, how would the X-44 Manta fare against the best that Russia and China can field? Let's examine Russia first. Russia's flagship stealth fighter is the Sukhoi Su-57. It's a fifth-generation jet that boasts super maneuverability, stealth features, and advanced avionics. However, experts and analysts have pointed out that the Su-57 stealth might not be as robust as American stealth fighters. It employs some stealth shaping and composite materials, but it still has noticeable external features like canards and large forward edges. From a purely theoretical standpoint, a stealth-optimized tailless design like the X-44 Manta could possess a significantly lower radar cross-section than the Su-57, making it harder to detect and target in a dogfight or in beyond visual range engagements. Over in China, the People's Liberation Army Air Force has its own fifth-generation stealth fighter, the Chengdu J-20. Known for its long-range capabilities and extensive use of stealth shaping, the J-20 is often compared to the F-22 and the F-35. China's rapid technological advancements have certainly given pause to Western analysts. Yet the J-20's canards and other design features have led some to question just how stealthy it is from certain angles. If the X-44 Manta's design truly eliminates the need for vertical stabilizers and tail surfaces while employing advanced thrust vectoring, it might indeed have an advantage in stealth and maneuverability. Add to that the potential for advanced sensor fusion, and it's easy to see why this aircraft might cause concern in Beijing and Moscow. Another angle to consider is the possibility of a drone or unmanned variant, with global trends moving toward UAVs, unmanned aerial vehicles, and UKVs, unmanned combat aerial vehicles. It's entirely plausible that the technology tested on the X-44 Manta could be adapted to an unmanned platform, one that could be operated remotely or via advanced AI. Taking a pilot out of the cockpit eliminates human limitations such as G-force tolerance, enabling an aircraft to perform maneuvers that would otherwise be physically impossible for a human pilot to endure. If Lockheed Martin and the Pentagon were to pursue such a path, the strategic advantage could be extraordinary. A stealth platform so agile and advanced that it could penetrate deep into enemy territory, complete complex missions, and evade or destroy threats without placing a pilot's life at risk. Of course, all of this begs the question, if the X-44 Manta is so advanced, is it really unstoppable? Every aircraft, no matter how sophisticated, can be vulnerable under certain conditions. Stealth technology can be countered by advanced detection methods such as infrared search and track IRST systems, over-the-horizon radar, and networked sensor arrays that use multiple radar frequencies. Speed can be challenged by long-range missiles that can close the distance quickly. Super maneuverability might be less of an advantage in an era dominated by beyond visual range combat, where engagements can happen dozens of miles apart, guided by advanced radar and sensor data. Still, if you combine an extremely low radar cross-section, high speed, advanced maneuverability, and a robust sensor fusion suite, you have an aircraft that is exceedingly difficult to neutralize. And that fundamentally is why adversaries are uneasy. When the Pentagon invests $300 million into a project, it's typically with the intention of future-proofing the U.S. military's air superiority for decades to come. That's the real endgame here, to maintain a strategic edge well into the 21st century. But the X-44 Manta was only recently acknowledged in any official capacity. As more details emerge, we may come to see that the Manta is less of a single plane and more a modular technology demonstrator, a step toward a new generation of stealth fighters that incorporate lessons learned from the F-22, F-35, B-2, and indeed, all prior stealth programs. The possibility that the final product might differ significantly from the conceptual X-44 Manta is also quite real. The codename Manta might even end up referring to an entire family of aircraft or advanced flight technologies. We should also consider the broader strategic environment. The arms race in hypersonic weapons, advanced missiles, and next-generation fighter jets is heating up. Russia has showcased the Kinzhal missile, a hypersonic weapon that can travel at speeds well above Mach 5, making interception incredibly difficult. China has demonstrated significant progress in both hypersonic glide vehicles and ballistic missile technology, designed to challenge U.S. naval assets in the Pacific. With these rapid advancements in missile technology, a stealth fighter has to be part of a more extensive system of defense and offense. That system includes satellites, early warning radars, electronic warfare suites, and alliances with partner nations. In other words, the X-44 Manta could serve as a crucial piece in a complex puzzle, but it cannot singularly guarantee dominance. Let's loop back to the question that piques everyone's curiosity. Why an invisible plane? Stealth technology in modern warfare is key, because the moment an aircraft appears on an enemy's radar, that enemy can scramble interceptors or launch surface-to-air missiles. Being able to approach targets or roam contested airspace unnoticed confers an almost insurmountable advantage. In historical conflicts, the ability to see the enemy first has often been decisive. With advanced stealth, the X-44 Manta might see and target adversaries long before they have any idea it's even in the neighborhood. This scenario is precisely why foreign militaries are investing so heavily in counter-stealth technologies and multi-band radar systems. The race between stealth and detection is an ongoing technological duel. One of the more intriguing aspects of the X-44 Manta is that it seemingly has an unobvious choice of primary weapon. While conventional aircraft carry advanced missiles like the AIM-120 AMRAAM for air-to-air engagements, or the AGM-88 HARM for anti-radar strikes, some whisper that the Manta might be trialing next-generation hypersonic missiles or advanced directed energy systems. A directed energy weapon, which could include high-powered lasers or microwave-based systems, might allow the aircraft to disable or destroy enemy electronics, sensors, and even missiles in flight without relying on conventional warheads. While still in development, directed energy technology has been progressing at a surprising pace, so the possibility that the Manta could be a test bed for such weapons is not outlandish. Now we must acknowledge that much of this remains speculative. The Pentagon's partial declassification does not mean everything about the X-44 Manta has been laid out neatly for the public. On the contrary, official statements often raise as many questions as they answer. This is to be expected. Military secrecy isn't just a habit, it's a strategic necessity. The known details likely represent only a fraction of the bigger picture. That said, the fact that we have any official confirmation at all points to the significance of the X-44 Manta in future planning. And when you consider that the U.S. is not shy about leveraging technology to maintain its global military edge, you begin to see why Russia and China would be uneasy. They have their own advanced programs, but the Manta's design philosophy and rumored capabilities suggest an enormous leap forward in stealth and agility. So is there any way to defeat an aircraft like this? The short answer is that determined adversaries will always look for weaknesses. Hypothetically, advanced multi-band radar, passive detection systems that rely on the aircraft's heat, or electromagnetic emissions, or integrated air defense networks could pose a challenge. Cyber warfare techniques that target the aircraft's sophisticated software and flight control systems could be another avenue of attack. Moreover, swarm tactics using drones or a high volume of less sophisticated missiles could overwhelm even the best stealth fighter. But these are only partial counters. The truth is, in a one-on-one confrontation, if an X-44 Manta pilot is backed by a robust data network and top-tier situational awareness, then any potential foe is in for a difficult fight. At this point, One might wonder how close the X-44 Manta is to being fully operational. The fact that it's referred to as an X-plane generally means it's experimental or developmental. It could be that the Manta is more a technological demonstrator than a near-term production aircraft. Historically, many X-plane projects yield key innovations that are later incorporated into operational platforms. Still, the real takeaway is that the concept of a tailless, stealthy, supersonic, supermaneuverable aircraft is very much on the table for the U.S. military. The research, the flight tests, and the data gleaned could shape the next iteration of American air superiority fighters, the rumored sixth-generation fighter. Whether or not the final design retains the X-44 name or is rebranded under a new designation is a detail that might be revealed in time. Let's summarize the highlights we've covered so far. The X-44 Manta is a Lockheed Martin concept that started in the late 1990s as a way to expand on the F-22 success, but push stealth and maneuverability to new extremes. The aircraft is tailless, relying on thrust vectoring for control, which helps maintain a minimal radar cross-section. Capable of speeds exceeding Mach 2, it may also have advanced supercruise capabilities. Armed with internal weapons and potentially exploring next-generation or even directed energy weaponry, it represents a major leap forward in how future wars in the sky could be fought. Partial declassification by the Pentagon serves as both a deterrent and a statement of technological prowess, sending ripples of concern to Russia, China, and any other nation that might challenge U.S. air dominance. All of this is exciting, if not a bit daunting. The prospect of an almost invisible aircraft able to outmaneuver and outgun just about anything in the sky might make you wonder about the future of air combat. Will it become purely a race to detect and shoot first? Will advanced AI take the pilot out of the cockpit entirely? Will directed energy weapons replace traditional missiles? The X-44 Manta exists at the intersection of these questions, and for every bit of information we learn, countless possibilities emerge. We should emphasize that while the unveiling of the X-44 Manta is remarkable, it's also part of a broader story of constant innovation and rivalry. Military superpowers know that the skies are the first line of defense and offense. The lessons learned from every major conflict in the past century show that controlling the air can make or break a nation's strategic and tactical objectives. That's why you have projects like the X-44, the NGAD Next Generation Air Dominance Program in the U.S., and counterparts in China and Russia that may still be classified. In this realm, knowledge is power, and knowledge has to be guarded fiercely. It's also worth noting that for all the rumors, the X-44 Manta might be only a fraction of the overall leaps being made behind the scenes. Hypothetical propulsion breakthroughs could further reduce fuel consumption, allowing for greater range and speed. Revolutionary materials that combine lightweight strength with radar-absorbent qualities could render even the best current stealth coatings obsolete. And we haven't even touched on quantum sensors or next-level data links that are virtually hack-proof. The X-44 Manta might be stealthy, fast, and lethal, but it could also be just the first step in an evolutionary chain of game-changing aircraft. One fascinating possibility lies in how the X-44 Manta might integrate with space-based assets. Future conflicts are likely to be heavily influenced by satellite constellations that provide real-time reconnaissance targeting data and secure communication channels. If the Manta can tap into these networks seamlessly and rapidly, it might be able to coordinate with drones, ground units, and naval forces at a pace no adversary can match. This synergy of land, sea, air, and space assets is the future of warfare, and an aircraft that can remain hidden, move at tremendous speeds, and deliver precise, lethal strikes could become the linchpin of that integrated approach. Yet for all its futuristic qualities, the X-44 Manta isn't just about abstract ideas. Behind every stealth panel, every advanced flight control surface, and every sensor is a massive effort in research, engineering, manufacturing, and testing. Thousands of people pour their expertise and passion into such a project. The $300 million figure often quoted is only part of the story. The actual cost, once you factor in decades of spin-off technologies and parallel development programs, is surely far greater. But those costs, in the eyes of the U.S. Department of Defense, are investments in a future where American air power remains unchallenged. To wrap up our exploration, let's consider the bigger historical context. Innovative aircraft that once seemed like science fiction eventually became legends of the aviation world. They were born from clandestine programs, revealed only after they'd already been operational for years. It's possible that in the coming decades, the X-44 Manta will join those ranks. A once mysterious prototype that either led directly to, or itself, became the next icon of American air superiority. By then, perhaps we'll have fully autonomous swarms of aircraft patrolling the skies, or scramjet-powered fighters darting around at hypersonic speeds. The X-44 Manta might be a stepping stone, or it might be a final, fully realized vision. Only time will tell. One thing is certain, in the realm of modern warfare, innovation is relentless, and the competition is fierce. The X-44 Manta stands as testament to that drive. To Russia and China, it's a clear reminder that the United States continues to innovate well beyond the status quo. And for aviation enthusiasts, it's a tantalizing glimpse into just how far we can push the boundaries of flight, stealth, and speed. Whether it's a direct deterrent, a technological demonstrator, or the precursor to an entire new generation of stealth fighters, the X-44 Manta's impact on both the military and the broader aerospace industry could be seismic. So what do you think? Is the X-44 Manta truly as formidable and revolutionary as suggested? Could it surpass adversary aircraft like the Su-57 and J-20 in a real-world confrontation? Or is it, at this stage, more of a conceptual leap than a reality we'll see in operational service anytime soon? Let us know your thoughts in the comments below. The speculation, the theories, and the facts all intermingle in a way that keeps us guessing, and we'd love to hear your take. And thank you for joining me on this journey into the heart of the X-44 Manta program. Keep your eyes on the skies and your mind open to the limitless possibilities that unfold whenever humanity dares to push the boundaries of what's possible. We'll see you in the next video.